Before we start studying atom and molecules and their working and the electron arrangements, I want to go through a short history of development of atomic theory and introduce atoms and molecules and their symbols and their models. About 430 BC, Democritus suggested that all matter is made of indivisible elements, which are called atoms, and is the same name that we use today. By 350 BC, Aristotle thought you can cut matter in half and always have a smaller piece, and you can do that indefinitely. He believed in four elements: air, earth, water, and fire. And because of the fame that Aristotle had, his theory stood up for centuries until the scientists start doing experiments, and through the experiments, they start noticing different properties of matter. So in 1803, Dalton proposed that matter is composed of atoms of different weights and is combined in ratios by weight, and atoms are spherical and in motion. And his proposal, his theory, started a new era for the atomic theory. In 1870, Crookes, a physicist, constructed a cathode ray tube, and in 1898, Thomson, using the cathode rays, he discovered a negative charge particle. When he was sending ray gas in this tube, he noticed that there was deflection of these rays, and he noticed that this deflection had a negative charge, and so he came up with this new particle, part of the atom, and was called electron. And he threw the idea of proton, but was later when Rutherford did his gold foil experiment that discovered the proton. But in early 1900, Planck introduced quantum theory, stating that electromagnetic energy could only be emitted in quantized form. So in 1909, Rutherford, with his gold foil experiment, discovered the positive charges, which he called protons, and developed a theory of the structure of the atom further. He said positive charges are in the middle, and the most of volume around atom is around them was empty space occupied by electrons, which were negative particles. In 1913, Bohr developed his atomic model, and this is the one that we use today, where he developed the Rutherford model further. He said these electrons move around the protons in different energy levels, and he introduced the different energy levels, different orbits. In 1931, Chadwick discovered the neutron hitting metals with a radioactive material. And in 1964, Mann proposed the quark model. All these development brought us to today's model of atom, which is perfected because we can do scaling, tunneling, like microscopic. Like we can have pictures of atoms through different fancy methods in the computer and have an idea of their of atoms model. So Dalton suggested a pure element is composed of atoms, and the atoms of each element are different in size and mass. Atoms are the smallest particles that take part in a chemical reaction, and atoms of different elements can combine to make molecules of a compound. They're all good, but Dalton didn't know that atom was made of smaller particles. And he also suggested symbols for elements, which is a form of chemical shorthand. Symbols consist of one or two letters from the name of the element. Some of them are in Latin. Now, when we have two, three different elements with the same that start with the same letter, we use the second also. So for carbon and calcium, they both start with C. For calcium, the symbol is Ca. And maybe you have noticed that some symbols don't fit with the word we say. For instance, sodium is Na and potassium is K. This is because the symbols were taken by the names in Latin. In that time, when they were discovered and the symbols given to them, the Latin language was being used. So we call sodium, in Latin, sodium is natrium, and the symbol is Na. And for copper is cuprum, for iron is ferrum, for silver is argentum, for gold is aurum, and for lead is plumbum. You are going to learn them all. So atoms are called the building blocks of matter. An atom is the basic unit of an element. It is a form of matter which may not be further broken down using any chemical means. If we break down the atom, it's not that element anymore. And it consists of three particles, subparticles: protons, which have a positive charge, neutrons, neutral, and electrons with negative charge. And Dalton introduced the idea of molecules to explain the particles making up compounds. For instance, water was made of two hydrogen and one oxygen, carbon dioxide with one carbon and two oxygen, methane of one carbon and four hydrogens. And the scientists noticed that some gases are made of molecules, not separate atoms, while iron is made of a bunch of iron atoms all together in a lattice. Some of these gases are not made with simple atoms. They need to have two atoms in their molecule, and they are called the atomic molecules. And there are 7 of them: it's hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. That's why we always write them with a subscript 2. These are the atomic molecules. One atom of hydrogen is not the hydrogen gas that we know. We need 2 of them. The same thing for all of those. So we said atoms are building blocks of matter. Elements are substances made up of one kind of atom. So hydrogen element is just an element, is not the hydrogen gas. As I mentioned earlier, we need 2 elements, 2 atoms of hydrogen to have hydrogen gas. There are more than 100 known elements today. 6 different elements make up 97% of the mass of compounds that are found in living things. And these are 6 main elements that are found in our body, and this plus 2% of other elements, but these are the main ones. And the oxygen has the highest part in our body making. Here we have some models of molecules. A molecule is made of atoms. So for those 7 gases, we need 2 atoms to make a molecule, the atomic molecules, and oxygen is one of them, 2 oxygens. Carbon monoxide is 1 carbon and 1 oxygen. Carbon dioxide is 1 carbon and 2 oxygens, and methane 1 carbon or 4 hydrogen. And you see the formulas, the number, the presence of the elements, and the number of each atom. It is expressed in the formula. We have O2, CO, CO2, and CH4. Now, I have here some examples of molecules. They are gas. I know they are gas because they are like spread, arranged, apart from each other, and if they were moving, they would be moving randomly. By now, you should be able to see an image and know what the matter is. So for the solids, we have regular structure, lattices, and we said they vibrate, the atoms vibrate, sorry. For liquid, we said they are really close, but they are not arranged regularly, and they move around each other. They flow. The particles in liquid and the gas, they are spread and they move randomly. So this is a picture of gas. So in gas, in this model here, we have 2 gases that have diatomic molecules. I would like you to find them. And there are 2 gases who have molecules made of 2 different elements. And this is the answer. If you say the blue and orange are the atomic molecules, you did great. Now, the blue is nitrogen and the orange is oxygen. How do I know that? Because there's another molecule here which has one oxygen and two others which are smaller. And because I understand the trend uh, in a periodic table, I know that the hydrogen is small, and I know this is the water molecule, and this one is carbon dioxide, because they have almost the same size. So uh, compounds are the one here, orange with two, red, which is water, and carbon dioxide. And uh, if you found the names of the compound, that would be excellent. But you just need to know that these two are the molecules with two elements. Now, for the next time, I'd like you to read textbook uh, lesson 3 in the chapter 2, atoms and molecules. And for homework, uh, you have a quick check questions, page 49, number 1, 2, and 3. Blessings.